Great. Hi, thanks for being here today for this webinar on the uses of citizen science and online courses. I'm Brianna. I'm the program manager for the Association for Advancing Participatory Sciences. It's nice to see some familiar names. We're partnering today with the Use CitSci Network on this webinar. I have a couple of housekeeping things and a few things about AAPS, and I'll turn it over to Heather and our other speakers. So the Association for Advancing Participatory Science is a new name for the Citizen Science Association. We've been around for over 10 years, and we connect people who do research by, for, and with members of the public. We do a lot of things. We have conferences and events. We have an online peer-reviewed open source journal. We have working groups, including an education working group that advances practices and creates resources for this community. And we also do skills building and learning activities. We have courses and are continually building out resources like that. On our new website, we have a growing resource library, including a collaborative knowledge base that has resources for educators, many of which were created by this team several years ago. We have a great archive of webinars on using citizen science in higher ed, on lots of other topics, including a data ethics toolkit that's really wonderful, a whole roundup of platforms if you're hosting a participatory science project, lots of great things on our website. We also have a journal, which is the field's place to publish research on theory and practice of citizen science. There's over 250 articles on many disciplines, places, and project types, including a special collection that Heather and others that are part of the Use CitSci Network helped edit a few years ago, and there's a great roundup of journal articles in there. I'm sure we might hear about some of them today and on today's call. We also do conferences. Our next conference, we just wrapped up our virtual conference last week, and I hope some of you were able to attend. Our next conference is in person next year in May in Portland, Oregon. We're really excited about it. We have a great local host committee that already has some great things in store for the events and field trips, which you might have heard about last week, but we hope you'll consider that for next year. And we also started piloting this year regional events, which is new. And I definitely wanted to just give a quick shout out. If you are interested in hosting a regional event, you can learn more on our website. But there are smaller, more intimate meetings and a great opportunity to meet other collaborators in your area. And like I've mentioned, we just concluded our virtual event, and every other year we host a virtual conference. It's a great opportunity to meet people and make connections across this field. We had multiple sessions on education and heard lots of posters and presenters from educators from across different disciplines. And so that's a bit about AAPS. We will be recording today's event to share afterwards, and so look for a follow-up email with a link to this recording and other resources from AAPS. And with that, I'm going to turn it over to Heather to get us started for the rest of the presentation.
Great, thank you. All right, let me switch to our slides here, and then we will get underway. Thank you all for being here today. We're going to start with some introductions of our team. So today, we are happy to host, and sorry, this picture just takes a minute to load, but it will indeed load. We're happy to share some of the information we have been working on the use of citizen science in online courses. I'm Heather Vance-Chalcraft from East Carolina University, and I will be one of the speakers here today. Let's see, Stacy, do you want to introduce yourself?
I'm Stacy Cotey from Michigan Technological University.
Amy?
Hi, I'm Amy Dunbar-Wallis from University of Colorado in Boulder.
Okay.
Hi, I'm Pankaj. I'm an instructor at the University of the People, Pasadena, California.
Great, thank you. All right. Well, okay. My slides are getting, there we go. So our plan for today is we will do some introductory information here at the beginning, and then we're going to talk about some tips and some lessons that we've learned from looking at the literature on the use of citizen science and online courses. Then we're going to go through a couple of different case studies of ways of a couple of different projects that have been used in online courses. That's not to say that they're the only projects that can be used in online courses, but it gives you some ideas of how that can happen. Then we're going to have some information about how to implement the use of citizen science in online courses and talk about some assignments and assessments that you can use associated with that. Then we'll have some time for some general discussion and wrap up. So that's the plan for today. And we really, in this webinar, are going to try to describe the results of a literature review of how citizen science has been used in online classes, but also provide very practical tips about ways that you might be able to use citizen science in your own courses. The objectives that we would like for you to know or be able to do by the end of this session is describe how citizen science has been used in online classes, provide examples of projects and platforms that can be used in online courses, and explain how to use citizen science to enhance learning in a course and reflect on how to effectively implement citizen science in your own course. So we want to start by having you all get into the chat and introduce yourself. If you can put your name and your institution. Let's see, I've temporarily lost my chat. Let me see if I can get my chat back here. I think we're here. All right, so now I can see the chat. Great, thank you. Welcome. Awesome. We have people from all sorts of places. Great. All right. Welcome, everyone. Welcome. All right. So in the chat, list some ideas of why you might want to use citizen science in teaching in a higher ed environment. What ideas do you have? Engage students in research with lots of data, students contributing to real data, creating field-based monitoring experiences, helps non-science majors get engaged. All right, active learning, authentic assessment styles. Yeah, those are all great reasons why you can use this sort of approach, these participatory science approaches with students in your classes. And it's really, the diversity of approaches that can be used and reasons for using it that makes this approach so attractive, I think, in classroom settings. But a lot of it comes down to, there's a lot of authentic, real world, real data. And I think that is really important to instructors who choose to use this method. One of the reasons they choose to use it is because it is data that has relevance outside the classroom. All right, there we go. You heard Rihanna mention the undergraduate student experiences with Citizen Science Network, and that is a research coordination network funded by the National Science Foundation. And the work that we're going to talk about today comes from a working group associated with that network. And we welcome you to check out more about the network at this website. The goals of the network are to create a broad community of practice of people interested in having citizen science in higher ed classes. Particularly, we want to help identify resources that are available to do that and develop recommendations for implementation and assessment. We also are trying to facilitate the adoption of citizen science in higher ed by disseminating useful resources. We'll be creating a peer mentoring system soon. That's kind of the next phase of the grant. And we provide various professional development and support. And finally, for people who are associated with citizen science projects themselves that think it would be helpful to have instructors incorporate these projects into their courses, we have been trying to help pair instructors and projects together and create resources to make that implementation easier. So I encourage you to check out our website. On our website, among other things, if you log in, so our website is hosted on the Cubes Hub. And if you'll have to create a Cubes account, it's completely free, and then join our network on the site, again, completely free. It's just a couple of steps in order to access the full set of resources. So you can see our webpage without being logged in or joining. But if you join the network and log in, then you can see one of the things that we have is a series of resource collections. And there's different resource collections, but one of them is some citizen science-based lesson plans. We have links to publications that are open access articles about this. We have videos for instructors or students, and different sorts of lesson plans. We've got all sorts of different things here, and anyone can upload materials to this site. So if you have materials of your own you've been using, feel free to upload. There's even an option to do it in a way where you get a DOI, a digital object identifier, associated with your resource, so that you can cite it and you can share it with other people and still receive credit for it. All right, so in the chat again, give us some idea of how much experience you have using citizen science in courses. So how many times have you used it? What kinds of courses? And were they online or in person? So if you can share that sort of information with us in the chat. None yet? All right, welcome. Happy to share some ideas with you. All right. It's helpful for us to know if we have super experienced individuals here who have done this a lot versus people who have less experience. I'm guessing the people who have more experience, it'll take a little bit longer to type. Okay, you are a student in some classes that use these approaches, some online and some in person. Okay, use one exercise. iNaturalist in person. All right. In a first year course and your online environmental science course. Awesome. All right. Great. So we have a bit of a mix, which is always good. So we'll have opportunity at the end so everyone can share their own experiences and your own lessons learned and tips for others as well. All right. Fantastic. Okay. So if you have had experience with this, what sorts of challenges have you faced? And we'll try and make sure we discuss some of those today. Did you have any challenges trying to use citizen science, particularly if you've done this in an online learning environment? What did you find most challenging about that? If you can put that in the chat. We'll give people just a minute to type. If you don't have experiences, that's fine. You can learn from others' challenges here. Databases, lack of student buy-in when intersecting it with a content-heavy course, confidence levels of educators, yes, tracking participation, finding projects that fit your learning objectives and can be done anywhere. Yes. I have found some fabulous projects, but it's very hard to fit them in with the academic year in some cases. For example, like it's like, oh, if I were teaching a summer class, I could do this, this, and this, but I'm not. So yeah, there's certainly challenges associated with that. The needs of the science versus educational needs, like how much can you monitor? How many skills do students have? Data management for students with little experience. Yeah, data management, depending on what you're doing with the citizen science project, that can be a big issue. All right, great. Thank you for sharing that. And then one last question for now. What questions do you have for us about using citizen science in online learning environments? And or what do you hope to gain from today's webinar? So again, we can try and make sure we incorporate those ideas and get to that during our discussion today. Teachers are time poor. Yes, everybody has too much to do and not enough time to do it. I agree. All right, so what do you hope to gain out of the session today? Or what questions do you have? And we'll ask this again at the end, but what is proven educational benefits? What hinders learning? Okay. the differences between citizen science and cures, ways to use citizen science in health sciences, and ways to use it for educational research measurements. Okay, so those are all great things that we can try to be sure to include either in our discussion or as we go, or at the end in the discussion. Yeah, this question of cures and citizen science, when I first started off, like that, they were two very distinct things in my head, but there is a gray area of squishiness, and you can, so if you're not familiar, cures are course-based undergraduate research experiences, and there's a few different principles for something to kind of fall into what a cure is. Things like they're novel, authentic research. There's some broader sort of engagement. There's iteration, relevance. So things like this. And citizen science, you know, is often driven by a scientist who has a particular research question. They're not always. There's also community science, which is driven from the ground up. But I think cures can use citizen science, but citizen science exists outside classroom environments. So that's kind of one distinction in my mind is citizen science projects. If they're only being done by students, then it's not citizen science per se. It's a very valuable learning experience, but it's not citizen science. Citizen science kind of exists outside of classrooms too. But when you think about things like the what is it, the Tiny Earth Initiative, Small Earth, you know, there are some initiatives that are multi-institution, but only in higher ed. And so in my mind, that's not citizen science because it's only in higher ed and not just anybody can access it. But there are some kind of gray areas about projects that are out there. Yeah, and I imagine Amy may have some other things to add in her section about that. All right, inspiration. That's a high bar, but we'll aim for providing inspiration, tips, strategies for course planning. All right, awesome. So let's hop in and get started. So as we're all aware, there was an abrupt switch to online learning during the pandemic. And because of that, there was a lot of increased interest in using citizen science in online courses. And so we had an interest in seeing what evidence there was in the literature for how people were using citizen science in online classes and what evidence was there for what was effective and what wasn't effective. Realizing that the pandemic was not that long ago, but some people were doing this long before the pandemic as well. So not knowing how many papers would be out there or not on this topic, we started doing a systematic review of the literature. And we searched through many databases, starting off with almost 4,000 papers that we were looking at in some fashion. And then we went through a process of exclusion until we got down to only 44 studies in 25 papers that met our inclusion for criteria, meaning that they were using what we considered to be citizen science projects and that they were being done in a higher ed environment and that they were being used in an online course. Okay, so not very much in the way of published studies on this topic. What we found is that the overwhelming majority of topics of the citizen science that were being covered in these studies had to do with biodiversity, specifically accounting for which species are present in an area. So that was by far the most common use. Over half of the citizen science projects that were used in this context were relating to the classification of species in natural history. And in many of these cases, projects were done completely online, and there are certainly citizen science projects that can be done online. And if you go to a platform like Zooniverse or SciStarter, and we can send those links out with you, which have lists of projects that you can select from. You can actually use keywords like online, and it will show you projects that can be done completely online. But in many cases, instructors in online classes were doing projects where students had to collect some data in person, but they could do it at whatever location was convenient to them. And so things like iNaturalist, or going out in their backyard or their house or a nearby park and collecting some sort of data. So many of these courses did have some in-person data collection needed, but it could be done individually in your own location. Most of the use of citizen science in these online classes was collecting and submitting data. Those were the most common ways that instructors were using these approaches. Less common was having people develop their own hypotheses, test their own hypotheses, analyze data, graph data, but it was certainly being done in some of these cases. And there's certainly opportunity to do those. Now, there's a variety of reasons why instructors said they were using these with their classes, and many of them have to do with the same reasons that you put in the chat at the beginning. They want students to be interested and engaged, particularly with non-majors. This seemed to be an overwhelming philosophy. So for people who were not science, who were teaching students who were not science majors, this was a way that instructors saw to engage and interest students. There's the relevance, the relevance of the data to the real world. You can teach the scientific process this way, and so on. There's a variety of different reasons that people wanted to use this. So then we looked at how effective the use of citizen science in classes was for each of these particular learning objectives. And unfortunately, what we found is that there is not sufficient rigorous assessment data to actually determine that. And so one of the takeaways for us was that we need to be encouraging instructors when possible to assess the efficacy of this method with students for the particular learning objectives that they have, so that we can begin to collect a database of information on that, and then future meta-analyses can be done, and we can draw some more rigorous conclusions about the efficacy. The anecdotal evidence that people report in studies is that they feel like it is very effective at engaging students and teaching this process of science, but there's not enough data to actually say that with numbers at this point. All right. All right, so now let's talk a little bit about how this could be implemented in classes with a couple case studies. So I'll pass it off to Stacy.
Thanks, Heather. So one of the most common citizen science platforms that have been used is iNaturalist, and here's the website for that. If you can go to the next slide, Heather. If you're not familiar with iNaturalist, anyone can enter data about species that they've seen on the landscape. And you can see here, in this is an example of monarch that was a monarch caterpillar that was reported. And you can also see all of the other reported incidences in that area as well. And so this is kind of the most common thing that's done with most of the projects, is the students entering additional entries into this iNaturalist platform. Okay, next slide. Yeah. So one of the first case studies is Brandeis University in Boston, Massachusetts. They implemented the iNaturalist citizen science platform in the conservation biology course. It's a large lecture course, and students were asked to submit field observations to iNaturalist, and they were looking at particular taxonomic groups or particular locations for data entry. And the additional objectives for the project were to give the students experience in using keys and guidebooks to figure out what species they were looking at. And then the professor gave feedback on any of the submissions that the students reported. So there was no requirement of, I think they had to at least do one entry, but there wasn't like a minimum other than the one entry. Next slide, please. In Lincoln University in New Zealand, they implemented this in an invertebrate lecture and lab course. So there were 2 3-hour labs dedicated to this, and the students had to complete 10 plant and pollinator observations and then submit them to iNaturalist. And again, they were looking at the use of keys and guidebooks and you know, helping the students go through that process of using a key. Next slide. Lincoln University also implemented it in their field ecology methods course. This was not obviously totally online or at a particular location, because the university has 6 permanent transects set up on their property. And so the students go out and run those transects. But you could still implement this on a fully online course by just having a student set up their own transect in a park or in their neighborhood or something like that. And they did do a little more analysis with the data. So they were taking the information they collected and also downloading the entries from the local area from iNaturalist to make comparisons of the species that they had found and that other iNaturalist participants had discovered. In Macaulay Honors College in New York, they implemented this in the Science Forward class, which is open to all majors, so it wasn't just biology majors. And what they did is a 24-hour BioBlitz of a campus green space. Again, this wasn't totally online or in separate locations, but this could easily be adapted to a fully online course with a student sampling at some other green space. And what they did is they had taxonomic experts, so professors from the department were available while the students were out collecting data, and they would assist with any identification of species. And then from the data collected, the students were to ask some sort of scientific question, usually about habitat and the relationship of biodiversity and different habitats on the campus. They were also able to extract and analyze data from iNaturalist to compare their results with other iNaturalist entries. And then North Carolina State University, in their Conservation and Natural Resources lecture course, they did indoor arthropod biodiversity study as part of the Never Home Alone project on iNaturalist. And the students were required to at least submit one observation from their home. So this one totally could be done online and at home. What they did is they had to find the species that were occurring in their home. And then they had them make comparisons of different species accounts from a pest management guide versus an ecologically based guide to see how these arthropods are perceived with 2 different contexts.
Hi, I'm going to talk to you about the eBird case study. eBird is a really great platform that I use in my classes that are not ornithology based. If any of you are familiar with the Merlin app, it's very addictive and can get you learning all the bird calls all the time, and that's what I use it for with my students. But this is the main website that you can see on this image, and if we can go to the next slide. So this figure draws from a paper that's about the structure of eBird and what happens behind the scenes. One of the things I want to draw your attention to is the top bubbles with computer science, conservation science, ecology, education, ornithology, and stats. eBird is really great because you could use this app in multiple different classes. If you've got students who need to learn R or statistics, it's a really great way to get lots of data really quickly. And it's also easily accessible from anybody in introductory biology classes all the way through graduate level courses. I use eBird and Merlin Bird ID in our community engaged semester-long cure with the Boulder Apple Tree Project, because we have students who are coming in as brand new majors and they don't have a whole lot of experience with birds, but we want to get an idea of what are the birds that are visiting our orchards. This is a really great way to get them to be able to identify those organisms while also contributing to a broader citizen science initiative. Okay, have the next slide, please. So while eBird has been used in over 1,000 different citations, we have one education citation for them. So we do have a really great need for folks who are using it to be able to document what's happening with their students and to do some rigorous assessments. So eBird was used at Clemson University in an undergraduate ecology lab. They used it across 8 sections in 1 3-hour lab session. And the students were being taught how to use different methods for observing birds in nature. And the students were documenting the number and type of species, and then doing some general sex, age, and health of those birds. Students were using both visual and sound observations. Can I have the next slide? So you can do lots of different types of learning objectives with these courses, but for this particular class, the instructors really wanted to introduce students to what citizen science is. The students were developing research questions using the data from the eBird database. And they also wanted the students to have better interactions with nature so that they can have a better understanding of the ecosystems around them. And they also wanted students to be able to describe different survey techniques for wildlife studies. And for the assessment of this, they used a student reflection instead of using survey data for the students. Can I have the next slide? And the students provided lots of different written reflection, but something that really stood out to me was this quote where a student said, "It really made me feel that I was actually making a difference and that there was more of a reason for me to be performing this lab rather than just for my educational gain. I really felt like I was benefiting a program and that there was more of a purpose for my actions and work. I almost feel as if citizen science should be taught more to the public and advertised more than what it already is." I feel like this student really summed up why we're all here very well. Okay, next slide.
And thank you. So I'll be discussing about how we can have a successful citizen science implementation in our courses. So it has been divided into resources like having a podcast and an implementation strategy, and as well as an assignment. Next slide. So the implementation part has been divided into pre-implementation, where we prepare before the students are actively engaged in the citizen science. The next part is implementation, where the students are actively engaged. And then is the post-implementation, where the students are being evaluated and we are self-evaluated. And finally, we reflect back. So what is pre-implementation? As I mentioned, it's a phase where we prepare ourselves for a successful citizen science implementation, which is the first part is inquiry-based learning, where the instructor will engage student in activity like Stump Your Partner, where the student will be asked to think and write a challenging question pertaining to the citizen science activity. Second is exploration, providing students with some resources about the citizen science and having them explore it independently and as well as in group. Finally, a share out, where the opportunity is given to students to collectively get engaged in one sentence summary or one word story, which is done by selecting a component of citizen science. So just to make students warmed up and get prepared for the implementation part, we have the pre-implementation phase. So during the implementation phase, we have the teamwork. During the teamwork, students can take up different leadership roles to complete the task. And then they can also use the self-documentation phase, such as the Google Doc, Google Sheet, Google PowerPoint, to create evidences, contribution of each group, and as well as each member. Next is the post-implementation phase. So most important, where we have the evaluation. The instructor can create a task where the whole set of group of students can get involved in academy, where they submit their individual as well as group work, and also organize a mini colloquium in the classroom, wherein the students can be divided into groups where they present part of their work. And also some of the students will move around in different groups, asking questions and clarifying their interest in citizen science or clarifying their doubts. And then the remaining students will also form groups and participate in the citizen science. Now, sharing a link to an instructor guide, and this guide will help you go through the task the instructor has to create and what the students will be following. And the last part of the reflection is the self-reflection and the group reflection. The instructor will engage students on the citizen science activity by having them reflect how they perform or what are their perceptions of citizen science. And then there will be a group reflection. Each group will reflect on the citizen science activity they just performed. Now, the next part is resource for the faculties to use to learn more about the citizen science. I'm sharing a link to a podcast. So this podcast is around 24 minutes, and it includes multidisciplinary speakers, which are having questions and they're answering to the best of their expertise and knowledge, how the citizen science can be implemented in your courses. Now, there are examples and perspectives on citizen science implementation and some future directions. Now, the last part is a learning journal assignment. Now, this learning journal assignment has been created using the podcast. So while you will listen to the podcast and apply your previous knowledge, you'll be able to answer a set of questions, which will increase your expertise in implementation of citizen science in your own courses, and as well as your own professional development. So there will be questions which you can answer without listening to the podcast. And then you can listen to the podcast and as well as apply your previous knowledge and answer a set of questions. And I've shared the link as well.
Great, thank you. Did you want to play any part of that podcast, Pankaj, or just?
Yeah, that's what I wanted. If you will be able to share, I can play the link. Can I share?
I think you are able to share as well. Let me stop sharing.
No, it says, yeah.
Oh, okay. So
here is the link to, first of all, the learning journal assignment, which will include a link to the podcast, and there are certain questions which are linked to the podcast and also without the podcast. Then this is a link to the instructor guide where the instructor can use these strategies. And these are the instructions for the students as well. And they have been divided into pre-implementation, implementation, post-implementation, and as well as reflection. And finally, here is the podcast.
Description setup, which is working to transcribe the field notebooks for researchers in the past so that they can be accessed via the internet and used by modern researchers. Transcribing field notebooks would seem like a fairly specialized activity that requires knowledge of species, geography, and other ecological information to ensure that the transcribed information is accurate. And you might think that people doing this work would be specialists with years of experience in that field. Well, let's let Siobhan tell us more about her background and preparation to do work for this project.
I'm an ex-lawyer. So I used to be a lawyer, and then I changed professions and became a wine salesperson. I worked in the wine industry for a while, and then I became a mum, a stay-at-home mum, and then I just progressed to citizen science and anything Wikipedia.
No formal education or training in science, but she's doing science. So is she a scientist or not? Well, let's find out what she thinks about that.
I definitely term myself as a citizen scientist. Whether I'd put that up to the next level of scientist, I don't know. I haven't received any formal scientific training, but I do regard citizen scientists as falling under the umbrella of scientists.
So, Dawn considers herself a citizen scientist. But what does that mean? And how does someone become a citizen scientist? Are there classes you have to take? And what does citizen science accomplish? Well, those are all the questions that we're going to explore in this bio episode. Citizen science is an exciting approach to research that is at the intersections of science, community, and education. Although the term citizen science first popped up in the 1990s, people have been involved in citizen science type projects for over a century. Perhaps you heard of the Christmas bird count, one of the longest running citizen science projects out there. And it's just one of the many projects that foster community engagement and contribute valuable data to scientific research. Whether it's tracking wildlife, monitoring air quality, or transcribing field notes, citizen scientists from all walks of life are making significant contributions to the scientific process. Citizen science projects can be a top-down type of thing, where a scientist has a question and they recruit community members to help them collect data. Or it can be a bottom-up endeavor, where community members have a question about where they live and they recruit scientists to coordinate their investigations. In this episode, you're going to hear from different people who are engaged in citizen science projects in some way. They will describe their projects, their motivations to do this work, and its impacts on science and society. And one really interesting thing we're going to get into is how they're using citizen science projects in their classrooms to shape the future of science and STEM education. So whether you're a seasoned researcher, a curious community member, or an aspiring student, this episode is sure to inspire more. So let's start with our first guest, Dr. Heather Vance-Chalcraft, a faculty member in the Department of Biology at East Carolina University. She and her students regularly engage with and contribute to a citizen science project called Caterpillars Count. She'll describe that project to give us a general idea of what a top-down, researcher-driven citizen science project is all about.
Caterpillar Count is an example of one of these kind of top-down, driven by scientists projects where really valuable data is used to collect it over broad geographic areas where one scientist can't do that by themselves. And so for Caterpillar Count, they're really interested in how their phenology changes over the species, and the seasonality of their different behaviors. And so it tracks the occurrence and abundance of arthropods on particular trees and shrubs over the course of different seasons. And so it has volunteers who use local trees or shrubs, and they monitor them regularly over growing season and submit that data into a national database so that we can check to see how the seasonal timing of the emergence of arthropods and peak abundances of arthropods is shifting over time. And it could also be related to the phenology of birds. So birds like eating arthropods, for example, and we know that climate change has been shifting some of the timing of different strategies in birds, times in which they migrate, times in which they reproduce. We know that climate change is impacting the timing of seasonality within arthropods, but the question is, can we start to get a mismatch? Historically, peak bird reproduction may be paired with peak arthropod abundance, a food source for some birds. But the question is, with climate change, we start to see a mismatch in the timing of those events. And citizen science allows us to collect data over a large area to begin to ask that question outside of a specific locality. Citizen science certainly brings a higher level of engagement and helps people experience the science that's occurring around us all the time, help us to recognize the patterns and the trends that are happening around us. And sometimes it's contributing data to a project that a scientist is interested in. But there are examples of related approaches where it could be a community themselves who has a question or a problem, and they want to begin to explore it using science. And so scientists or other people can pair with them to help them determine how can science help provide data or evidence to document some patterns that they're interested in exploring. The community can be engaged either through a data collection sort of process or through actually collaborating and co-creating the entire project itself.
Okay, that's an example of a top-down kind of citizen science project. Let's now learn about a more bottom-up type of project called the Boulder Apple Tree Project. And to do that, we'll hear from Dr. Lisa Corwin, professor in the Department of Ecology and Evolutionary Biology at the University of Colorado, and her graduate student, Amy Dunbar-Wallis, who will describe the project and its goals. You'll hear from Dr. Corwin first, and then Amy will come in a little bit later to describe their demonstration orchard.
First and foremost, the Boulder Apple Tree Project started as an effort to understand the historic cultivars that are still in existence here in Boulder County and to preserve those cultivars using grafting and also using genetic identification of the trees to see which ones are here and how rare they are, because we have a lot of information from other entities such as the USDA, et cetera, on just the rarity of some of these really cool historic cultivars. People around Boulder often have these agricultural tracts of land, and many of the residents of Boulder County have small orchards on their land. They have chosen varieties that are a little bit more popular today, usually to plant, but they also, some people have orchards that they specifically want to plant heirloom varieties because they're very interested in cultivating those for their value for cider, or because they're just interested in preserving these cool historic trees. And we have actually planted recently our very own orchard in North Boulder. So it's just north of the city, and it's on a small tract of land just off of J Road.
It's on reclaimed prairie dog habitat, so it's a wonderful restoration project as well. It borders an existing large farm that has been separated by a road having been moved. So it's this little tiny triangle of land. And what's great about this is it's now a demonstration orchard where we can interact with the community on all the different aspects of establishing and caring for an orchard. All of our trees were created from local historic and heirloom cultivars. So we're very excited about these trees.
We've been relatively successful at identifying which cultivars remain here, which was one of our large goals to start out. So we've been able to submit for genotyping over 200 trees, and we've discovered many really cool things. We've held multiple grafting workshops, teaching people how to take basically twigs or scions from these historic trees and then join them with dwarf rootstock so that a new tree can be planted with the same apple cultivars. So we've been able to do that. We have hundreds of new trees across the landscape now that are from these historic cultivars that have been a result of our grafting workshops and grafting efforts, and also those trees that exist in the orchard that Amy just spoke about. And now our goal is to continue that preservation, but also to support people in these orcharding efforts. So we would love to partner with people and have more small heirloom orchards across the region. And we have a lot of interest in that. So that's kind of our next step. As you can tell, there's a lot of different multifaceted purposes to this project, but I think the broadest way to state all of them are that we seek to preserve the different historic cultivars, that we're hoping to understand the ecosystem services of apples in the region, apple orchards and individual trees, and that we're also hoping to engage students with community relevant work that they can then learn from and take the skills from and go do their own community relevant projects after they graduate.
But for citizen science in general, if folks have a specific interest, there's a lot of citizen science groups out there, and it's just a quick internet search away, and they'll likely find something. And there's always iNaturalist. So getting local organisms on iNaturalist is a really great way to start.
And that brings us to another citizen science project called iNaturalist. This project allows users to take pictures of plants, animals, fungi, basically any wildlife, and then submit them to the iNaturalist site where they identify the species or ask others to help identify them. This project contributes valuable data to scientific research and conservation efforts. However, some biologists are using iNaturalist in another exciting way. They're engaging their students with iNaturalist as a creative way to teach them not just science facts, but also teach them about the process of science and so much more. To learn more about this interesting application of citizen science in general, and iNaturalist in particular, I spoke with Dr. Pankaj Mehrotra, a biology professor at the University of the People, who some of you may remember from our earlier podcast episode on biofilms. He's going to describe how he uses iNaturalist and citizen science in his classes.
We'll stop here, and that's around half of the podcast. So what I have to further share is a resource which we have on QBIS Hub, which integrates the learning journal assignment and as well as the podcast. Thank you so much, everyone, for listening.
All right. So you have some links to some of those assignments. The next thing we want to do is kind of have some general discussion. So I think it might make sense to start with some of the topics that came up in the chat earlier. Sorry, I've lost my chat again. Let me get that back. And if anybody on the panel wants to respond to any of these, that'd be great. So let me see. Let me get back up here. Which sorts of questions did we have? Amy, is there anything you wanted to add about cures versus citizen science and the, it doesn't have to be mutually exclusive. You can do both. Anything you wanted to add?
Yeah, so we actually have a paper coming out. We have 2 papers from our lab coming out here, hopefully in the next 2 to 3 months, about community engaged cures. And community engaged cures can use citizen science. They don't have to. You can do cures in a modular format where it's, maybe 1 class session or up to 2 weeks worth of classes, or you can do a whole semester long. I'm fortunate enough to get to do semester long cures where I can use multiple different citizen science platforms to help our students with learning about their local environment. So like I said earlier, I do use eBird and Merlin for different aspects of our students learning about the organisms that are around apple trees where we are, but we're also offering our cure at different schools throughout Colorado and northern New Mexico. Another way that we use a different citizen science project is we use the Budburst, Project Budburst. I don't know if you're familiar with that. It's been really great because we're on semesters and Budburst typically doesn't play very friendly with those of us on semesters. If you're on quarters, Budburst is really great because you're more likely to capture when leaf out and flowering is happening. But it's a great way for us to get our students to understand what's happening locally, but also to provide data to larger national and international networks. Citizen science doesn't necessarily have to be an international or national level project. It can definitely be very local and very place-based.
Great, thanks. So what other questions do you have? Feel free to either unmute and ask or type it in the chat. And we want to make sure that we are answering any questions that you have today. While we're waiting for that, I will say, I'll put in the chat links to SciStarter and Zooniverse. And each of those sites has educator pages. So if you navigate to educator pages for those, one of the questions that came up was like tracking participation. There are ways that you can set up kind of a class account through the SciStarter website, and it has ways, and if you follow the basic instructions on the educator pages, where it can help track what projects your students are contributing to and how much data or how much effort they're contributing to different projects. So say, for example, you wanted to give them the option of 5 different projects and let them choose the one that's most of interest to them. It can help track their participation in that. In some cases, that student choice can be a really powerful tool if you want them to kind of just, if your learning objective is something like student engagement or positive attitudes about science or possibly process of science. Now, if you want them to know exact content, then you're probably going to choose a specific project, but there are different reasons that people use these in their classes. But those educator pages have ways to help track attendance or participation in the project. So that can be done that way. There are also some assessment instruments out there that can be used with these sort of classes, but not a lot of instruments. I can send a link to some of those to people in attendance. There was an NSF grant several years ago now that created a bunch of instruments for use with citizen science in a variety of contexts, but it's called the DEVISE project. So if you were to Google DEVISE assessment tools, we would probably come up with it, but I'll also send the link. And they have a number of instruments that you could use to measure things like self-efficacy for environmental action. So say you want your students to come out of this experience feeling more inclined towards environmental action. There's things like that there. That's one set of assessment tools. Now, there's certainly loads of other assessment tools that could be used from the educational literature. They're just not all assembled in one tidy place. Great, thank you. There's a set of instruments in this paper as well. Great. So those are some ways that we encourage people to assess their participation. What other tips or questions do people in the who are here who have used this approach? What tips do you have for somebody or lessons that you learned through your experience that you're willing to share with people? You can either unmute or type it in the chat. All right, well, a couple more things I'll throw out there to think about. And I guess we'll get some of these in a later slide slightly too. But think about things like data quality. Students will almost certainly ask you about data quality after participating in this sort of experience. Like, can we really trust data that's generated by non-experts? And the answer is that if there are good training resources for participants, study after study has shown that the quality of the data between experts and non-experts is very comparable. Now, there are some slight exceptions of certain types of projects that are less user-friendly for that, but there's loads of data to demonstrate that there is good data quality. But because if we use this in a classroom environment, I do just encourage people to think carefully about how you structure your assignments, such that you're not encouraging students to have bad data ethics, because this data is being used for other sorts of purposes potentially too. You don't want to incentivize just entering data into the platform without having students carefully think about the quality of the data that they're collecting. So you can think about that as well. Great. Yeah, please continue to stick helpful tips into the chat, and we'll make sure people get all the links from the chat as well. All right, while people think about any additional questions or comments, we have a few other things dealing with implementation and kind of summarizing some of the information that's out there. There's a variety of ways to include citizen science in higher ed. You can, there are entire courses, and there was some reference in the chat to a couple courses that sounded like they were all about citizen science, and that's great, that's fabulous. but it doesn't have to be that way. You could use a tiny little module within a course to present citizen science. You can complement your course content through research, through community engagement, using citizen science literature to complement course content, just to show that this is a valid way also to get scientific information. You could have a variety of different learning objectives for using these courses. And there's a bunch of different potential assessment types that you can do. In class or out of class assignments. You can monitor how long or how sustained their engagement is. You can do things individually or by groups, and you can even assess involvement with communities and local partnerships. Some tips that people have told us in the past, and we have come up with ourselves from implementing citizen science in course environments. Do make sure that you have run through the entire project yourself before you ask your students to do it, because some bumps in the road will certainly result that you don't anticipate. And if you have done it yourself, you will have much clearer answers to how to proceed in certain situations. Do try to align the choice of project and what you're having them do on the project with your course learning objectives. If they feel like this is like completely unrelated and not integrated well with course content, things will not go as well as if they feel like it's aligned well. That being said, your objective might be to develop a more positive attitude about science, in which case, so many different projects would align with that particular objective. Make sure that however you're having your students interact with the project is helping to support the project goals itself. So again, if they're entering data that is quality data, that they are understanding the project goals and how to participate. Create appropriate incentives and grading strategies. So as I said, don't just give more points to people who enter more data without any quality checks at all going on, because you don't want to encourage people to be unethical and add data that they're falsifying or things like that. Encourage attention to data quality, scaffold in the assignment so that if you're asking them to identify things, that you are providing training and scaffolding to help students do that, and checks to make sure that they have reached a certain competency level. A lot of projects have that built in now, where the training resources help you learn to identify things and have quizzes so you can check your accuracy and things like that. Verify that students are doing what they say they're doing. You also need to give some thought to student privacy, particularly if you're having students participate in a project that geolocates them, that has data that is collecting about where they are at a particular time. So think carefully about what the project app is actually collecting. And there are ways to get around things. You could set up one class account that every student uses. For example, if you have an online class and students are collecting data at their home, it is not necessarily appropriate to make it so that the latitude and longitude of their home is accessible to any user, but there are ways around that. So most apps or websites for educators provide some examples of how you can do that, but it is something you need to think about. You also have to think about whether you're requiring them to join the project to create their own account. And there's different philosophies about whether that's appropriate or not, and whether or not they have the digital accessibility to do that in an online setting. So just be aware of those sorts of issues. And then also, many projects now are fairly accessible to people with a variety of accessibility issues, but not all. And so you will need to give some thought to that as well. If you're having students go out and collect data, is it something where people with physical challenges would be able to collect or not, and other sorts of accessibility issues as well. So those are some things to think about. Now, it seems like a lot of good things were coming up in the chat too. Did anybody have anything that you want to point out from that?
Heather, do you want to address about where the largest gaps are about achieving learning objectives? That's a question that came up in the chat.
What are the largest gaps in what we know about achieving learning objectives? Well, the reality is that there's not enough rigorous assessment data to actually know that for online settings at this current point. So some instructors don't talk about assessment at all if they have. So out of those 25 papers, some of them don't describe assessment much at all. Many that do describe it in a way where there's not numbers associated with it for us to really determine what is happening. But and the most data that is out there that I would say in papers is reflection data. So there are a number of papers that have student quotes or instructors summarizing the sorts of things that students said. So I would say there's the most evidence, if any, about engagement, interest, those sorts of things, because of reflection sort of data that has been collected from students. But even that could certainly be done in a more, rigorous way, and we need more evidence in that as well. There has been some evidence about science process skills or science literacy that comes from these sorts of endeavors in higher ed settings, but not, we need additional replication in those sorts of areas. In informal learning environments, there's data certainly that people can learn disciplinary content this way, that you can have affective changes, and that there's an increase in the process of science, but it's and a little bit of evidence in that in primary and secondary school K-12 settings as well, but not as much in higher ed at this point. So we really need more rigorous data in that. Lots of anecdotal evidence that says these things are effective, but we need more rigorous data. Anybody else know of other examples or things they want to throw out there? All right, so have we found strong evidence that certain approaches, tools work better than others? So I think you need a project that has good training tools. It depends on what your learning objectives really are. If you want students to work with data from the project, there are certain projects that definitely have data in a more accessible manner for students than others. So there's some projects that have done a really good job of cleaning their data and making it so that it's pretty ready to analyze. The Caterpillars Count, for example, they have excellent visualization tools where you can create maps and stuff directly on their website, so you don't have to learn yet more programs. They have data that's very easy to download and very clear instructions on how to do different types of analyses, and examples of analyses that one could do. Other projects, their data might be available, but exactly how people upload it, which means there's going to be a lot of data cleaning and data management that needs to happen. And that may or may not be what you want your students to be doing with their time. So it depends on the objectives that you have for them. And then there are some projects for which the data is not available at all, except by request or potentially at all. That's becoming more rare, but you want to look into that ahead of time if you want them to include the data analysis portion. Some people just want their students to learn how to sample and want them to see that citizen science exists, in which case you don't need to worry about the data on the back end. But those are concerns that I've seen. And then the other thing is the timing. The seasonality is the other thing that we've seen a lot of challenges with. Like Amy mentioned, like doing bud burst on a semester system can be challenging depending on where you live. So things like that, I think, are things to really think carefully about. There's a question. Oh,
sorry, can I jump in about how transferable do you think lessons are between online and in person? So we offered our Apple Tree Cure during COVID, and students used a lot of different citizen science platforms to aid in their research for that class. And I felt like it was very transferable because we had those students then, many of them continued on to do independent study research with us in later years. So I think it's very transferable.
Yeah, agreed. Agreed. There's also
Yeah.
a question about, was there a unified effort for community science on campus, or is it involvement based on individual instructors? So I know there are some campuses that are like citizen science campuses or community science campuses, but I think those are relatively rare. There are some universities that have like a first year effort to like involve everybody in these sorts of efforts. But I think most of the experiences that we've heard from instructors are single instructors who think this is great, or a small group of instructors at a single university that then pick up excitement and steam and they help each other out. I think in most cases it's not a campus-wide initiative, but which is unfortunate, but I think that's the way many things work these days. All right, well, we will follow up with you all by email with links to various resources and from us. And then I believe AAPS may also do that. So you will receive information from us. If you did not register and got the link from somebody else, please do just go ahead and go back and fill out that registration form, because that's how we'll know how to follow up with people with resources. I'm happy to hang around for a few minutes if people have any questions or comments that you want to have. But that is what we had. Is there any final words that anyone else wanted to have?
I just think it's sometimes a little challenge to get it started, but it's like a really great experience for the students. Like I've had very positive comments from my students.
There is a question in the chat about some of our results that we had. It's in review. We have not put it out as a preprint yet, but we're hopeful. We're working our way through review. So hopefully it will be out before too long, and we will send that to people once it's out. Brianna, did you have any final words?
Great. No, just thanks to all our presenters and thanks everyone for joining us today.
Yeah, thank you so much. We appreciate your time, especially in the summer. I know everyone's busy. But... All right, thank you.